So now let's look at problem 2. A track coach applies 3 different treatments to 3 different groups of runners to decrease their time in a 2,000 meter race. Test the claim that there is a difference between the mean decrease in race times. Use alpha equals 0.10. So it says test the claim that there is a difference. We always start off H naught with mu1 equal to mu2 equal to mu3. Because there are 3 different groups, we're stopping at mu3, and we can also see from the data that there are 3 different groups. We always start the alternate hypothesis with at least one mean is different, and really that's kind of where we end it too, but because we're testing if there is a difference, that is our claim, the alternate hypothesis. Next, I always think it's best to find the critical value. We need to start by finding the degrees of freedom for the numerator of our F test. And this is the number of groups minus 1. And we can see that we have 3 minus 1, or 2 groups for our number of columns. Now we're ready to find the degrees of freedom of the, the degrees of freedom of the denominator for our F test. And this is the count of how many numbers there are minus the group. So we could add up how many numbers we see. So 5 plus 4 plus 3 minus the 3 groups, or 12 minus 3 is row 9. And remember, using the F table, we'll have to go to the individual table based on alpha, and we can see that alpha is 0.10. So from that table, column 2, row 9, I see the number 3.01. Next, I need to create data for my test statistic, which starts with adding up the values of each group. So, 30 plus 42 plus 35 plus 55 plus 48, although you're probably not doing that by hand. Remember, you should be entering that into a list of data on your calculator and looking for the output for the grand total. For list 2, it's 236. For list 3, it's 180. And maybe you aren't doing 1 per row. You're starting with group 1, and you're finding the 4 important pieces of data we need to find. I just tend to write it this way as I'm lecturing, since I'm not actually finding them by scratch at this point. The count is 5 items. Again, your calculator should be telling you that. 4 items and 3 items. Next is the average. Reading off my calculator, 42 seems reasonable. The average of group 2 is 59, and the average of group 3 is 60. And last, I need the variance from group 1, which, remember, I'm going to have to take the standard deviation from group 1 and square that to get 99.5. Great, it ended. I don't have to round that decimal. The variance for group 2 takes the standard deviation and squares it to get 258. And the variance for group 3, I take the standard deviation I see on my calculator and square it to get 4. I needed a second screen. It's all the same information. But now I'm ready to find the test statistic. I start with finding the grand mean. This is where I'm going to take all of the numbers and divide by the count. So I'm going to add each number from within the list. But again, remember, we've already started taking those totals. So it's much easier to take the 210 plus the 236 plus the 180 and divide by the count, which I've also already indicated. So the 5 plus 4 plus 3 to give me 626 divided by 12 for a grand mean of 52.1666. That I'm going to have to round. But as I look back and glance at all these numbers, 52 feels a little high, but there is some high 50 numbers in that 82, so hopefully that's right. Next, I want the variance between means. So remember, I take the count from the first group and multiply it with the average from the first group and subtract the grand mean, which I'm going to round to a 3-digit number, and I square that subtraction and move on to the next one. The 4 items in the second group times their average of 59 minus the grand mean, quantity squared, and then I'm going to take the 3 times the 60 from the third group, subtract the grand mean, square, and divide by k minus 1, which remember k is the count of groups, and in our case we only had 3 groups. So 887.6666 divided by 2. I didn't round before I divided by 2, so I get this ongoing number. Now I'm ready to find the variance within the groups. This is where I take the count minus 1, so 5 minus 1 is 4, times the variance that's already listed. I don't square anything. I just multiply it times the 99.5. And for the next group, I'm going to take 4 minus 1, which is 3, times the variance for the second group. And again, 3 minus 1 times the variance, which actually happens to be a pretty small number. And I divide by all of those subtracted counts that I just calculated. You're probably just doing the math in your head. I'm writing each number so you know why I'm dividing by 9. And I get a variance within means, within groups, to be 131.111. So for the F test, I take the ratio of the between means, because B comes first, of that 443.833 rounded number, and divide by the variance within the means, which is my 131 number, and I create a test statistic of 3.385, etc. But I'm only going to go 2 digits to the right, where my 8 is going to round up to be 339. We had already found a critical value of 3.01. I just forgot to write it over. And now we're ready to decide whether we reject or fail to reject H0. I got to start with my curve, starting at 0, writing numbers in order. Even though 301 is listed second in my box of information on a number line, it's to the left, and so I label it critical value. My next number was the 339. I label as a test statistic. This is always a right tail test. We always shade from the critical value, and therefore my test statistic is in the critical region. We reject H0.